All right, guys, so we are at day 4 now of our online learning. And so we're going to continue on with the greatest common factor. The difference is today is we are going to introduce polynomials. And polynomials just means that now it's going to have 3 or more terms. So now instead of 2, we have 1, 2, 3 terms that we got to factor out of. Now, first thing we're going to do every single time is figure out our numbers or our coefficients. So we have 4, 3, and 2. So we're going to create ourselves a tree. So we have 4, we have 1, and 4, 2, and 2. For 3, we have 1, and 3, and for 2, we have 1, and 2. So if we're trying to find the greatest common factor, the only factor they have in common is going to be the 1. And so if you want to, you can go ahead and you can put a 1 out here. However, we're going to know that a 1 is understood, which means you don't have to leave it there. But for now, we'll leave it there just to kind of keep its place. So in reality, 4, 3, and 2 does not have a number greater than 1 that we can pull out of it. So now we got to move on to the variables. And so with the variables, we have p to the 5th, p to the 4th, and p to the 3rd. So really, we have p times p times p times p times p. And then for p to the 4th, we have p times p times p times p. And p to the 3rd is 3 p's. So how many do they have in common? Now, we could also just remember that we're always going to pull out the smallest exponent. Well, the smallest exponent in this case is the 3. And if you will notice, they all have 3 p's in common. So we're going to pull out p to the 3rd. Now, something else we cannot forget is that our leading coefficient is a negative, so therefore we also have to pull out a negative. Now we have pulled out all that we can, so now we can start filling in our parentheses. So we know we're going to have 3 different terms inside our parentheses since we started with 3 terms up top. So now, negative 1p to the 3rd times what will give me negative 4p to the 5th? Well, we know we're going to have a 4, and then we already have 3 p's, so how many p's are we missing? And that is 2. Now, negative 1p to the 3rd times what is going to give me positive 3p. So since we need a positive, we're going to have to multiply by a negative 3. And then since we have 4 p's up top, we need 3 p's. So we need 1 more p. And then negative 1 times what is going to give me positive 2. That's going to be negative 2. And since we already have 3 p's, we are done. And so that is going to be your final answer. So that is the direction that we are heading today. Let's do a couple more examples. So this time we have 4, we have negative 8, and we have 16. So we need to make our factors 4, 8, and 16. So we got 1 and 4, 2 and 2, 1 and 8, 2 and 4, and that's it. So then we have 16, 1 and 16, 2 and 8, and then 4, and 4. So if we're trying to find our GCF, or our greatest common factor, between 4, 8, and 16, it looks like it's going to be 4. So we're going to factor out a 4. And now this time, they actually do not all have an x. So the second term, negative 8x squared here, it has an x, and 16x to the fourth has an x, but the 4 does not. So we cannot factor out an x this time. So we're going to go ahead and start our parentheses. And now 4 times what will give me 4? That's going to be 1. 4 times what is going to give me negative 8x squared, and that's going to be negative 2x squared. And we have 4 times what will give me positive 16x to the fourth, and that's going to be positive 4x to the fourth. Now, with these, can you also check them? And the answer is yes. So if you were to redistribute this back out, 4 times 1 is 4. 4 times negative 2x squared is going to give you negative 8x squared. And then 4 times positive 4x to the fourth is going to give you positive 16x to the fourth. So it checks. So therefore, our answer is right there. Now, third example, we have negative 20x to the fifth minus 15x to the fourth plus 10x to the third. So the better we get at these, the more we can start recognizing that we have 20, 15, and 10. So the largest number that is going to go into these is going to be a 5. And so, since it is a 5, we are going to pull out a 5. But we also have to pay attention to the fact that its leading term is a negative. So we're going to pull out a negative. And then we got to see the exponents. So we have x to the fifth, x to the fourth, and x to the third. So the lowest exponent is x to the third. So that means we are going to pull out x to the third. Now we can figure out what's going to be left on the inside. So negative 5 times what is going to give me negative 20, and that is positive 4. And if we have 3 x's but we need 5, that means we're missing 2. Negative 5 times what is going to give me negative 15, and that is positive 3. And we have 3 x's but we need 4, so we are missing an x. And then negative 5 times what is going to give me positive 10. That's going to be negative 2. And since we have 3 x's and they already have 3 x's, we do not need any more. So that is it. And that would be the answer you get for that one. Now, this last problem was on the Delta Math, and it is one that a lot of people miss. So just to kind of clarify on it real quick, this one is a binomial. It only has 2, but we have an x squared and we have a negative 7x. Now, once again, there is a 1 hanging out in front of the x squared, but that is understood. So it's not always there, but that's going to be the GCF that we pull out. So we can pull out a 1, but then the thing that we really need to pay attention to is each term has an x. Now, this negative 7x is really negative 7x to the first power. So the lowest amount of exponents is going to be 1x. Then we can fill in our parentheses. So x times what will give me x squared, and that's just going to be x. X times what will give me negative 7x, and that's just going to be negative 7. You can erase the 1, and so your final answer would look like that one.